Alright, so here we are with part 2 of day 2. So Heron's formula. You've seen this before. Area equals the square root of s times the quantity s minus a times the quantity s minus b times the quantity s minus c, where a, b, and c are the sides of the triangle, and s is a plus b plus c divided by 2. It's called the partial perimeter because it's the perimeter divided by 2. S is used because p is perimeter, so we don't want to get confused. So I want you to find the area of the triangle given A is 3.05, B is 0.75, and C is 2.45. Pause the video, unpause when you're ready to check your work. Okay, so first I found the partial perimeter. Add up the sides, divide by 2, I get 3.125. So then the area is the square root of 3.125 times 3.125 minus 3.05 times 3.125 times 0.75 times 3.125 minus 0.2 or 2.45. Type all of that into my calculator exactly as it's written, and I get 0.613. Alright, moving on to 2 more applications and then we are done. So 2 ships leave port at 9 a.m. One travels at a bearing of north 53 degrees west at 12 miles per hour, and the other travels at a bearing of south 67 degrees west at 16 miles per hour. How far apart are the ships at noon? Okay, so I want you to pause the video, try to solve this, unpause when you're ready to check your work. If you are struggling setting up the diagram, then you can at least watch that part and then try to solve from there. So pause the video now. Alright, so here is my diagram. So if this is port and the one ship was traveling north and then 53 degrees west, that's going to be this angle here. So the ship is up here and the other ship was traveling south 67 degrees west, so that ship is down here. So this represents the distance between them. Since I was given speed, and I know that they were both traveling for 3 hours because they left at 9 a.m. and it's noon now, I can multiply speed times time to get distance. So this ship traveled 36 miles, this ship traveled 48 miles. I know this angle is going to be 60 degrees because this is 180 degrees minus 53 minus 67. So then I use the law of cosines. X squared plus 36 squared plus 48 squared minus 2 times 36 times 48 times the cosine is 60. X squared becomes 1872, so x is 43.267 miles. Therefore, the ships are approximately 43.267 miles apart at noon. Very good. Alright, a parking lot has the shape of a parallelogram. The lengths of 2 adjacent sides are 70 meters and 100 meters. The angle between the 2 sides is 70 degrees. What is the area of the parking lot? Pause the video. Unpause when you're ready to check your work. Okay, so here in black I drew my parallelogram and I knew that the one side is 100 meters and the other side is 70 meters. And that the angle between the 2 sides is 70 degrees. So I drew in the height of the parallelogram. This is probably, I believe this is the simplest way to solve this. There are other ways in which you could solve this using the law of cosines and Heron's formula, but that's a lot more work. So then I know sine of 70 equals h over 70 meters. So h is approximately 65.778 meters. Therefore, area of a parallelogram is base times height is 100 times 65.778. So I get 6577.848 meters squared. So the area of the parking lot is 6577.848 meters squared. Again, that's the simplest way to solve this. You could have, drawn your parallelogram, known that this is 70, 70, 100, and then use the law of cosines to find this side, and now you have 3 sides to a triangle, and you could find the area of this triangle, multiply that by 2 to get the entire area of the parallelogram. It's a lot more work. I would just do what I did. And so again, the thing to note here is try to find the simplest way to solve a problem, assuming it's still correct. You don't always have to use whatever technique we were just studying if there is a better way, unless you're specified on how to do it. But if you're not, find the simplest way. Okay, so we want to make sure we know the law of cosines, understand the law of cosines, love the law of cosines, know how to use the law of cosines. I didn't do it on any of the examples, but I talked about it. If you start with law of cosines and convert to law of sines, and you started with side, 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 then you need to find the largest angle first. If you started with law of cosines and it was side, angle, side, then you switch to law of sines, you need to find the smallest remaining angle next. Also know Heron's formula, great way to find the area of a triangle.